Hi algebra students. Okay, today is part 2 of simplifying expressions using multiple laws of exponents. We're stepping it up a notch, so today's lesson at times will be okay and at times will be kind of confusing, so you might want to expect to refer back to this video a couple of times before you have a decent understanding. Just as a quick review, because hopefully we have all these rules memorized, the product rule, you're multiplying two terms together, you will add exponents. Quotient rule, you are dividing two terms and you will subtract exponents. If you have a power to a power, you will multiply exponents. The zero exponent rule, anything raised to a zero power equals 1. And the negative exponent rule means you make a fraction out of it. If you have a to the negative 1 over b to the negative 1, you switch the location. The b to the negative 1 becomes the numerator, the a to the negative 1 becomes the denominator. Okay, now we're going to apply a bunch of different rules. We may approach different problems in different ways. It's just going to depend on how they look. We're looking for the path of least resistance and what will make the most sense and hopefully be easiest to us. Number 1. How these problems are different from the ones we did yesterday. We're not just multiplying terms together, we're also dividing terms. So it's going to throw a little bit of an additional step into it. Also, when you do have these quotient type problems, there's always implied parentheses around your numerator and around your denominator. So a lot of times you're going to want to simplify everything in your numerator before you look at your denominator, but that's not always the case. If we wanted to simplify and reduce this fraction right now, we could cancel out the x squareds with the x, make it x to the first on the bottom, and then cancel with our x squared. But it becomes kind of confusing and messy, and when these problems get messy, they're very hard to follow. So I think what we want to do first is simplify our numerator. We only have 1, 3. Our operation is multiplication, and we have to do x squared times x squared. And we know when we're multiplying, we add the exponents. So in the numerator, we will get 3x to the 4th over x to the 3rd. Now we're dividing, so we will subtract exponents, and 3 will stay 3, and we have 4 minus 3, and we'll get an x to the first power. You don't have to write the 1 there, but it is always implied that it's there. Okay, number 2. Yikes. We have one of those outside exponents. But when you look inside the parentheses, there's some simplifying that can be done before we raise every single number and variable to a power. So I think that's the approach I want to take with this one. Now if you think back to your pre-algebra days, they would have you line up your y's, and you'll put one y on top, 3 y's on the bottom, you'll cancel those y's, and you're left with 2 y's on the bottom. So I kind of just mental math these. I'm like, yeah, 1 y on top, 3 y's on the bottom, leaves me with 2 y's on the bottom. Or, if you apply the exponent rules, you would have y to the first minus 3, because it's a quotient here, which would give you y to the negative 2, which eventually would give you 1 over y squared. Yeah, and now you're there, but you could have been there a lot faster. You already knew there were more y's on the bottom. So why don't we just take that approach? 4x is going to stay 4x. There's nothing to simplify it with. We'll have 2 y's on the bottom. And again, we're raising this all to the second power. We don't want to lose sight of that. Now that everything is simplified on the inside, I'm going to raise everything to the second power. Do a quick rewrite. 4 squared, x to the first squared, all over y squared squared. Okay, let's just simplify. 4 squared will give us 16. X squared stays x squared. When we have a power to a power like we do down here, we multiply. So 2 times 2 will give us 4. And we have 16x squared over y to the 4th. Okay, hopefully that didn't seem too bad. It's nice when all of our exponents are positive. Number 3. Again, I've got numbers, I've got variables, x and y, and I have, the outside power. So I think what I'm going to do first is treat this as a series of mini problems. Rewrite 6 over 2, x squared over x squared, and y to the 4th over y. And so I don't forget that variable, put a 2 out there. Okay, 6 over 2 can be simplified to 3. X squared over x squared can be simplified to 1. And y to the 4th over y, depending on how you look at it, is going to leave you with y to the 3rd on top. You can pretend there's a 1 here and do the math, and the exponent for the quotient rule of 4 minus 1 is 3, or you can think back, you've got 4 y's on top, 1 y on the bottom. That leaves me with 3 y's on top. And then don't forget we're still squaring it. Okay, last step hopefully. Distribute this 2 to every single term. So you'll have 3 squared times y to the 3rd squared. Alright, we're almost there. 3 squared is 9. Power to a power, we multiply our exponents. We get 9y to the 6th. Okay, if you need to pause it, rewind it, think about things, try the problem again. It's not a bad idea before we move into more difficult problems. Okay, next page, number 7. Now we're going to throw some negative exponents into the mix. But they look similar because there's still operations that I can simplify within the parentheses. These are fractions I can easily reduce. So I'm going to draw my little imaginary lines and try to treat them like mini problems. I might even do a rewrite depending on how difficult the problems are, just so I don't lose anything. So I'm going to rewrite it as 12 over 3, x squared over x, and I only have a y term and it's just in the denominator, so I'll rewrite it as 1 over y. And still don't want to lose that negative 2. Well, we should know that 12 divided by 3 is 4. X squared over x, 2 minus 1 is 1, so that will just leave me an x to the 1st power. And 1 over y, there's nothing to reduce there, so we'll leave the y in the denominator. But now we have the negative 2 to take care of. The negative sign itself makes this fraction flip. So you can rewrite this as y over 4x, and you still have to remember to square it. Now maybe we can mental math this, because we don't really have a whole lot going on inside. When we square y, we'll just get y squared. 4 squared, now remember 4 is in your denominator, but 4x is in the denominator inside this parenthesis, so we have to raise it to the 2nd power. So when we raise 4 to the 2nd power, you're going to get 16. And then when we raise x to the 1st to the 2nd power, we get x squared. And I always look at my final answer to see if I can reduce it. And in this case, I can't. Alright, number 8. A lot going on here with number 8 as well. There's a couple different ways to approach it. We can simplify the inside, or we can distribute the negative 3 to all of our terms. I think to be consistent, I'm going to stay with simplifying the inside, and I'm going to take care of these negative exponents first. Now even there's a couple ways you can approach this. You can approach this as 3 times x to the negative 5th minus a negative 2. Yikes, huh? And keep that to the negative 3rd power. When you're subtracting a negative, we change both signs. Okay, so far so good. So we have 3x, a negative 5 plus 2 would be negative 3, all raised to the negative 3rd power. And now we could take it a step further. 3 needs to be raised to the negative 3rd power, and x to the negative 3 to the negative 3, we can also do some evaluating there. This 3 to the negative 3 is the same as 1 over 3 to the 3rd. This x to the negative, we have to multiply those two terms together, and we'll get a positive x to the 9th. One more step, and I think we've got this. Raise 3 to the 3rd power in your denominator, and you get x to the 9th over 3 times 3 times 3, which is 27. Yeah, it gets very confusing when there's a lot of negatives in place. All right, number 9. Whew. All right, this is another one. Let's try to tackle it from the inside and then work out. Okay, so we have 6. We have x to the 3 minus a negative 4. And we have y to the negative 1 minus 1. Wow, that's a lot going on there. Change your signs. When you have a double negative, add the opposite. And let's keep in mind we're raising this whole thing to the negative 1. Notice we really don't have a denominator anymore because we did 3 minus a negative 4 and negative 1 minus 1. Even though you don't see it, it's there. Alright, 6, there's nothing we can do with that one. X to the 7th, and then I'm adding 2 negatives together here. A negative 1 minus 1 becomes a negative 2, all raised to the negative 1 power. Now let's distribute that exponent. So we have 6 to the negative 1, x to the 7th to the negative 1, and y to the negative 2 to the negative 1. Okay, so we can turn this into 1/6, right? Because that'll make this go to the denominator. 7 times a negative 1 gives you x to the negative 7th, so that has to end up in the denominator. And y to the negative 2 times negative 1 gives you a positive 2, so you get y squared in your numerator. Okay, I think that's good enough for today. Tomorrow we'll start with some more multiplication problems. All right, good luck. We'll see you in the morning.